All right. 0.4, our last section of this preliminary unit that we're in before we start our 8th grade book. Okay, it's over multiplying and dividing fractions and decimals, or what we call rational numbers. So what I'd like you guys to do first is I'd like you to take, I don't know, a minute or so and answer these 6 questions that you would have done from last week, all having to do with multiplication and division. And my goal is to remind you of how negatives work in our dividing and multiplication problems. So take a minute or so. Jace, what would you get for negative 6 times 8?
Negative 48.
That's right. Connor, what about negative 56 divided by negative 7? Good. And Seth, 6 times negative 9? Good. Yep. Remember, there, if you just squeeze multiplication together, or squeeze numbers together like that using parentheses, it shows that we're multiplying. Jimmy, what about 72 divided by negative 8? Good. Owen, Oliver, negative 4 squared.
16.
That's right. That's right, because negative 4 squared actually means negative 4 times negative 4, and the 2 negatives make a positive. So that's going to give us positive 16 if I can write there and not erase. And then Xander, negative 3 times negative 2 times negative 1.
Negative 6.
That's right. If we have 3 negatives, 3 is an odd number, and the whole answer is going to be negative. And then of course 3 times 2 times 1 is just 6. Now take these rules and apply them to fractions and decimals. Okay, it's easier. Yesterday, I want to say last week, you guys did it last year even. Yesterday, we worked with negatives as well, but we were adding and subtracting. So we had to rewrite all of our subtraction problems to addition. Yeah, that's not happening today. We're going to do the problem like normal, and we're just going to count and see, are they both negative? Okay, make it positive. Is one of them negative? Make it negative. Do I have 3 negatives? Make it negative. If I have 4 negatives, make it positive. It just keeps going. They keep alternating back and forth between negative and positive, depending on whether you have 1, 3, 5, 7 negatives. Negative, that's odd. Or if you have 0, 2, 4, 6 negatives, in which case they all pair up, and that's positive. Okay? Because it's even number of them. So remember, to multiply or divide with negatives, all we have to do is count the negatives. When you count the negatives, you're either going to get an even number of them, in which your answer is positive, or you'll get an odd number of negatives, in which case your answer is negative. Other than that, it's fractions and decimals as normal. So why don't we start with decimals? We did that yesterday. I also told you yesterday that I think working with decimals is easiest when you're adding and subtracting. Today, I think we'll find out that it's actually easiest to work with fractions when you're multiplying and dividing. So multiplying decimals, write the longer number on top. The longer number. Here's what I mean by the longer number, not the larger number. The longer number. If I'm multiplying, for example, 6,284 times 26, how would you write that? Would you write it like this? Or would you write it like this? Which of these seems more natural to you? Xander?
First one.
The first one. Now, it seems more natural because I put the larger number on top. But in the instructions, I said put the longer number on top. Well, here's why I'm saying longer instead of larger. Well, hold on a second. There we go. 26 is bigger than 6.284. But because I'm used to seeing it like this, I'm going to write it like this. Okay. Put whatever one has the most digits on top. Okay. Then you can multiply and count the negatives. After you do that, one additional step we have to do for decimals is count the decimal places. So remember that if one number has one decimal place and the other number has one decimal place, your answer should have two decimal places. Add them together. Oliver, what if the first number has two decimal places and the second number has one decimal place? How many decimal places should I have? 3. Just add them together, right? Now, I'm going to give you a little secret about how I do these problems. I do not even write the decimal in the problem. Did your teachers tell you to do this last year? Just write them as whole numbers? I'm not getting any. Okay, let me show you what I mean. Instead of writing 4.26 and 7.8, I'm just going to write 426 times 78. The decimals don't affect the numbers I'm going to get. They do affect my answer. So when I'm done, I'm going to apply those decimal places. But for right now, this is our problem. Slide this down so we have a little bit of room to carry. What's 8 times 6? Anybody?
48.
48, carry the 4. What's 8 times 2? 16 plus 4 is 20. Carry the 2. 8 times 4? 32 plus 2 is 34. Now what do I do? Go ahead, Jace.
You cross out the 8 and then put a 0.
That's exactly right. Yeah, I'm going to put a 0. And the reason we're putting a 0 is because we've now moved into the tens column. This is actually 70 that I'm multiplying by now. So I need to put a 0, and then I'm going to cross these out, or you can erase them, whatever you want to do. And we're going to start fresh. 7 times 6, anybody?
42.
42, carry the 4. 7 times 2, 14, plus 4 is 18. 7 times 4,
28.
plus 1 is 29. Now I'm going to add them together. I know you guys remember doing this, and I probably didn't give you a whole lot of space if you're writing big like I am, so I'm going to shrink this down. We're going to add them together to get 8, 2, 12, 13, and 3. 426 times 78 is 33,228, but that wasn't our problem. Our problem was not 426, it was 4.26 and 7.8. So I count, and this is the same question I just asked Oliver. If you have one decimal place or two decimal places in the first number and one decimal place in the second number, Oliver, how many decimal places is that? So I'm going to put a decimal after. Actually, if I start counting on this side of the problem, I should count over 3 spots, 1, 2, 3, and put my decimal place right there. So I have 3 decimal places. So it's actually not 33,000, it's just 33.228. That all you did last year. And I know you guys worked with negatives last year too. So tell me how the negatives apply. What happens if I have 2 negatives? Standard?
It becomes a positive.
It becomes a positive. All the rules are meshing together right now. All my multiplication rules that I already know with decimals, plus the multiplication rules that I know about integers, meshing together right now. Let's move to the next problem. Negative 2.5 times 3.64. Jace, which number has the most digits?
3.64.
Yep, so I'm going to write 364. Now you're free to write the decimal points in the problem. The reason that I don't is because I see a lot of students line up the decimal points. Do not line up the decimal points when you're multiplying. That is only an adding or subtracting thing. Same with fractions. Do I have to find a common denominator when I'm multiplying fractions? No. I have to line the denominators up when I'm adding them. I have to line the decimal points up when I'm adding decimals, not when I'm multiplying. So to ensure that I don't even try to line up the decimal points, sometimes they line themselves up, I get that. To ensure that I'm not forcing them to line up, I don't even write them. Because you know what happens if you force them to line up? Here, I'll show you. Decimal point, decimal point. You're going to end up putting a 0 there, aren't you? Which first of all is going to throw everything off because you're going to get zeros across the board. Then you're going to drop down to 0 when you shouldn't have dropped down to 0. Then another reason that people get the wrong answer. 1, 2, 3, 4 should have 4 decimal places. Should have 1, 2, 3. There's a couple reasons you don't want to force the decimals to line up. Because adding those extra zeros is not something I want to do. Oh, I didn't want to erase the whole thing. Hang on a second. I just want to erase this and that and that. And that's the whole thing. Okay, fine. We'll start over. 364 times 25. What's 5 times 4? 20, here are the two. What's 5 times 6 plus 2 is 32. 5 times 3 plus 3 is 18. Drop down a 0. And I'll just erase those. Or if, by the way, if you're working in pencil, you could just scratch them out. That's what I usually do. Just put a line through them. What is 2 times 4? 2 times 6. Carry the 1. 2 times 3 plus 1 is 7. I'm going to add these together, and that's going to give me 0, 10, 11, and 9. And so it's not 9,100. It's actually just 9.1 because I have 1, 2, 3. I'll circle them for you. Decimal places. Do I have to actually write 9.100? What's that the same as, Xander?
9.1.
Yeah, you can just write it as 9.1. I mean, I wouldn't count it wrong, but it doesn't look right. It's too many decimal places. It's not actually too many decimal places. It's just that once we move the decimal point, we find out that 2 of the decimal places aren't even necessary. Okay, last one. What's 5 times 5? 25. Yeah, that was easy enough. How many decimal places do I need? 3. Okay, so I start here and I count over 1, 2, oh, oops. I need another one. What should I put in that empty spot, Seth? A 0. This is actually going to be 0.025. 0.025. What's 2 negatives make? Positive. What about up here? What's 1 negative make? Yeah, that's an easy way to get it wrong. I adopted right there. It's an easy way to get that one wrong. You gotta remember the negative signs. 1 negative makes your whole answer negative. So this is positive 0.025, or you could put a 0.025. I don't care if you put the 0 in front of the decimal point or not, as long as you make your decimal point big, so I can see it. All right, let's move on to dividing decimals. Yikes, I hate this part. I hate this part because it means I have to do long division, which is nobody's favorite thing to do, especially without using a calculator. So dividing decimals means I'm going to set up a long division problem by putting the first number, what we call the dividend. The first number goes inside the box. The second number goes outside the box. Then what I'm going to do is I'm going to take the outside number, the divisor, the second number, I'm going to make sure it's not a decimal anymore. So I'm going to slide it over, slide that decimal point over as many times as I need to. Okay, so let me show what I mean. Example A here, 125.6. Yes, you do have to write the decimal places. That was just a multiplication thing. Divided by 0.08. Now I'm not going to make you write the negative, because you can tell right now that with 1 negative number, our answer is going to be negative. So I'm just going to put the negative right there, where I'm going to write my answer. Now, step number 2 said move the outside decimal point. Since we have a decimal in that outside number, what I'm going to do is I'm going to slide it over to where I don't anymore. So 1, 2. Now it's just 8. Now instead of dividing by 0.08, I'm just dividing by a whole number, 8. You can legally do that as long as you also move the dividends decimal point the same number of times. So if I had to take the outside decimal point and move it twice, I need to take the inside decimal point, move it twice, float it up to the top, and put what in that blank right there? Seth? A 0. So 125.6 divided by 0.08 is actually the same problem as 12,560 divided by 8. I'll get the same answer. And it's easier for us to do. How many times does 8 go into 1? It doesn't. Yeah, it doesn't. How many times does it go into 12? Once. Okay. Subtract, I get 4, drop down the next digit, which is a 5. How many times does 8 go into 45? 5 times. What is 8 times 5, Xander? 40. Look how nice and neat this is. I have to make sure that I am lining up my numbers correctly. I get 5 as my remainder. I drop down the next digit, which is 6. Jimmy, how many times does 8 go into 56?
7.
Exactly 7 times. I'm going to subtract. I'm going to get a remainder of 0, but I'm not done because I still have a spot right there. So I drop down the next digit, which is that 0 I was forced to add, and 8 goes into 0 how many times? 0. Now I can be done. Now that I've got every spot in front of the decimal point filled in. Negative 1,570. It's gonna be pretty easy to see who's using a calculator on their homework, isn't it? Like if I don't see long division, if I don't see this, it's gonna be pretty obvious what's going on, right? You're either using a calculator or you're copying off somebody who did it correctly. Okay, can't copy, obviously. Can't use a calculator until this preliminary unit's over. One more. Which number goes inside the division box? Someone other than Xander. Connor Kendall. First number, good. 8.722 goes inside the division box and the 35.6 goes outside. Let me write that correctly, 35.6. And then I'm not writing any negatives because I can check that part of the problem right now. Jimmy, if I've got two negatives, my answer will be positive. I'm just going to put a plus sign right there to remind myself I've checked it already. Whatever works for you. The outside number, AKA divisor, has a decimal point. I don't want it to. So Oliver, how many times do I need to move the decimal point on the outside number? Once. How many times do I need to move it on the inside number? The same number of times. Yeah, sometimes I see students just slide both decimal points to the end. I can't move one of them once and the other one 3 times. That's not going to fly very well. How many times does 356 go into 872? If you had to guess, Jimmy? 2 times. You know it's not 3 times because that'd be over 900. Okay, let's try 2. I'm going to have some side work here. 356 times 2. 12, carry the 1, 11, carry the 1, 712. Yeah, we're not going to get any closer than that. And because I went into okay, sorry. So I should have asked you how many times it goes into 8. You would have said 0. I should have asked you how many times 356 goes into 87. You would have said still 0. So I guess I'll put a 0 right there to just remind myself to check that. Now we'll put the 2 right here, right above the 2 in the 872, and then I'll put the 712 and we'll subtract. Jimmy, what's 2 minus 2? 7 minus 1?
6.
And 8 minus 7. Good. Drop down our last digit, which is also a 2. 1,602 now. Any guesses as to how many times 356 goes into that, Xander?
4.
I'm gonna guess 4. Okay. By the way, if you're wrong, you shouldn't erase your side work because you might need it later. I see people do that. They'll erase it if they're wrong. It's like, whoa, how do you know you weren't going to use 2 later on the problem? So times 4, that's Xander's guess. 6 times 4 is 24. Carry the 2. 4 times 5 is 20. Plus 2 is 22. 4 times 3 is 12. Plus 2 is 14. I think that's as close as we're going to get. So I'm going to go ahead and put the 4 right there. I'm going to put the 14, 24. I'm going to subtract. Xander, what happens if you can't borrow from a 0? Yep. And then that becomes a 10, and then actually it becomes a 9 because it's immediately going to get borrowed from, so that this can be a 12. Xander, what's 12 minus 4? What's 9 minus 2?
7.
5 minus 4?
1.
And 1 minus 1? Okay. Now, if we reach the end of the problem and we still are not finished because we have a remainder, we just start adding as many zeros as are necessary. Hopefully not too many, because I do have dinner to get to. 1,780. Any guesses? We know because of our side work, it's got to be more than 4. Any guesses, Jace?
5.
5. Okay, 356 times 5. 5 times 6 is 30. 5 times 5 is 25, plus 3 is 28. 5 times 3 is 15, plus 2 is 17. That's exactly what we were looking for. Perfect. So our answer is going to be positive 0.245 or just positive 0.245, however you'd like to write it. Again, you don't need to write the plus. That is long division. Now let's get to the fun part of tonight's homework. Let's work with fractions now. Multiplying fractions. Yesterday, I showed you how to multiply, sorry, I didn't show you how to multiply. I showed you how to add and subtract when they were still mixed numbers. Do you remember this? Kind of cool. You can't do that today. You have to, which is why your teachers told you to convert them all to improper fractions last year, because you got to anyways when you're multiplying and dividing. So you have to convert it. It's not optional. Step 2 is definitely an awesome step though. Cancel. Fractions have to be reduced. When you multiply, you have the option to, instead of reducing at the end, you can reduce them at the beginning before you multiply. Have you ever multiplied numbers together and gotten a really, really big answer? Yeah, that doesn't happen when you cancel because you've shrinking those numbers down, which makes you reducing a ton easier. You're gonna have to do it anyways. You might as well get it out of the way and do it while it's easy. Okay, do it while it's easy. Then you're gonna multiply across the top and bottom. You're gonna count the negatives. Did I even do that in the last problem? Yeah, I did. We checked the negatives. I forgot that once already. And then do not find a common denominator because we're multiplying. Just like I said, do not line up the decimal point when you're multiplying. It's just an adding thing. That's just a subtraction thing. It's not multiplying. So let's multiply these fractions. Let's see here. Seth, how do I turn the number -9 into a fraction? That's right. I think you told me that yesterday too. Okay. Oliver, what's 2 negatives make? Okay, so it's positive. You know that. Here's what I mean by canceling. Instead of just doing 5 times 9 to get 45 over 18, and then trying to reduce that, what I can do instead is I can look for things that can cancel now. I can cancel any top number with any bottom number, even if they're diagonal from each other. For example, the 9 and 18. What goes into 9 that also goes into 18? Seth? 9 itself. 9 will go into 9 once. 9 will go into 18 twice. What about the 5? Does it 5 cancel with anything? Doesn't reduce anything? Okay. So 5 times 1 is, and 2 times 1 is 2. And did I say yesterday you could leave these as improper fractions? Okay, because you can. You can, regardless of what problem you're working on, whether it's add, subtract, multiply, and divide, you can leave your answer as a reduced improper fraction. Meaning I don't want 10/4, but I'll take 5/2. Example B. These are both mixed numbers. Jimmy, will you tell me what negative, well, first of all, let's not even worry about the negative. There, our answer is gonna be negative, right? Because one of them. Jimmy, will you tell me what 3 1/3 is as an improper fraction? Got it. Yep. Remember, he's doing 3 times 3 plus 1. And Xander, what's 2 7/10 as an improper fraction?
27 over 10.
Okay. Raise your hand if you see something that cancels. Everybody's hand should be up. What do you see, Connor? Oh yeah, 10 and 10. Boom. 10 goes into 10 once, 10 goes into 10 once. I'm reducing, but I'm just doing it diagonally. You can also do it straight up and down, but you're not going to get 27 and 10 to reduce, but 10 and 10 will. Anything else? Oliver? Yeah, 3 goes into 3 once, and 3 goes into 27 how many times? 9 times. So then I'm left with 1 times 9, which is 9, over 1 times 1, which is 1. Now, the only time that I will not allow you to leave your answer as a improper fraction is if there's a 1 on bottom. This is the only time where canceling doesn't actually get it reduced all the way for you, because I need to recognize that -9/1, just like Seth said earlier, -9/1 is actually just -9. So I don't want -9/1. I want -9 as your answer. Reduce it down. Okay. If you cancel as far as you can cancel, you'll never have to reduce except for right then, where you just need to go ahead and write it as an integer. Now, if you're not on the canceling bandwagon, this is going to get you on it right now. Because while you're trying to figure out 27 times 11 without a calculator, and then 55 times 36 without a calculator, we're going to go ahead and cancel it. By the time you're done with 1/2 the problem will be finished. What do you see that cancels? Jimmy?
55 and 11.
Exactly. 11 goes into 11 once, and 11 goes into 55 5 times. That's going to save us a ton of time. Jace, do you see anything else that cancels? There is something that cancels. While Jace is thinking about it, I just want to remind you that when I say cancel, it doesn't mean that I'm looking for that same number to go into itself. Like it just so happened to be when Jimmy canceled 1155, 11 went into itself once. That's not always the case. Jace, can you think of a number that goes into 27 that also would go into 36?
9.
You got it. Yeah, 9, we can cancel by 9 here. 9 goes into 27 3 times. And Jace, how many times does it go into 36?
4.
4 times. That looks like as far as I can cancel. Although if I could do 3 and 4, 3 and 5, I would definitely do it. I just can't. So what's 3 times 1? And what's 5 times 4? And how many negatives did I have? Yeah. I'd still be trying to figure out what 27 times 11 is right now. Instead, I can cancel all the way down. So I just have to do that. I mean, literally, this is why I think multiplying fractions is easier than multiplying decimals. I can do this in my head. All I have to do is cancel. Dividing fractions. You should remember this from last year and the year before. Obviously, convert your mixed numbers or whole numbers, like Seth did with 9 to be 9/1, convert them into improper fractions. And then I'm looking for 3 words here. What 3 words can I use to divide fractions, Xander?
Keep, change, flip.
That's right. Keep, change, flip. That's how you multiply, or how you divide fractions, by actually changing it into multiplication. Notice where this third step is located. Cancel. That was the same step we did last time, right? But look where it's at. You can only cancel multiplication problems. So you have to change it to multiplication and flip before you can cancel. Do not try to cancel before you flip the second fraction. -2 is the same as -2 over what? 1. Now we're going to keep, we're going to change to multiplication, and we're going to flip to 1/2. And by the way, the negatives are gone. What's 2 negatives make? Positive. Don't waste your time with it. Do you see anything that cancels? 3 and 2, 3 and 4, anything cancel? No? So did we just waste our time there? No, because if it doesn't cancel now, it's not going to reduce later. So even checking now is still good. It will not reduce for us. What's 3 times 1? Bless you. And then 4 times 2? Yeah, it's 3/8. And 3/8 doesn't reduce because it never canceled. What's 2 negatives make? Positive again. Okay. Jace, can you tell me what 2 4/5 is as an improper fraction?
14/5.
Got it. Okay. And then this is going to be divide by 7/1. Or you could actually, if you want to, go ahead. You know you're going to have to keep, change, and flip it. What's 7/1 flip to, Connor? 1/7. Okay, I'm okay if you do that step in your head. Just don't forget. Okay, don't forget it. What cancels, Oliver?
14, so
That's right. 7 goes into itself once. 7 goes into 14 twice. So Oliver, give me your final answer. That's right. That's it. Wow. I thought we were going to be at that for a while. That's it. So just like yesterday, you've got 2 more textbook pages. Remember, this is not your Big Ideas textbook. Otherwise, we'd be doing it online, right? I get that. This is actually, if I don't think I told you this yesterday, this is Florida's textbook, which we don't have access to. I like how they have multiplying and dividing in the same section. I like how they had adding and subtracting in the same section. Ours didn't work that way. I told you I'd have to assign you 2 homeworks if we did that, and I don't want to. In fact, I'm going to in a couple of weeks, and even then it kind of gets confusing. Yeah, we do geometry problems. I'm going to give you guys surface area of prisms and cylinders at the same time. I'm going to give you volume of prisms and cylinders at the same time because they use the same formula. So you'll have like 6 homework problems here, 8 homework problems there. 1 homework, 2 different sections. I'm not a big fan of it, but I only do it twice, or it's actually 2 different times. Anyways, here's your problems. And here's the ones you're doing. Starting at number 10. 11, 12, 13, 14, 15, 16, 17, 16, 18, 21, 22, 23, 24, 25, 26, 28, and then 29 through 33, 37, 46, 49, B and C. 49, there's an A, B, and C. You only have to do B and C. What pattern do you notice? And then once you notice the pattern, what would be the sign of -2 to the 49th power? In fact, let's talk about that right now. Might as well since it's here. It says consider -2 to the first power, -2 to the second, -2 to the third, -2 to the fourth, -2 to the fifth, -2 to the sixth. What is -2 to the first power? Xander?
-2.
That's right. What's -2 squared? Someone other than Xander. What's -2 times -2, Jace?
4.
4. Jimmy. Take your previous answer, multiply it by another -2, right? That's what we're doing, just another -2. What's 4 times -2? -8. Okay. Seth, what's -8 times -2? -8 times -2? Positive 16. Okay, stop right there. Forget the numbers for a second. What pattern are you noticing with the signs, Vander?
It goes negative, positive, negative, positive.
Negative, positive, negative, positive. Every time you raise it to a, what kind of number is this? Odd or even? Odd, odd, odd. Every time you raise it to an odd power, you're going to have an odd number of negative signs. Because, for example, this is going to give you 5 negative signs. It'd be 5 -2s. What did we say was true when you had 5 negative signs? Odd or even? Oh, sorry. Odd. Positive or negative? Negative. Every time you raise it to an odd power, you get a negative answer. Every time we raise it to an even power, the negatives pair up because there's an even number of them and you get a positive answer. So that's the pattern you notice. I would write odd, even, or something like that for 49B. What about 49C? What's the sign? Not even what's the answer. Be really big or really small. It's negative, if it's negative. What would the sign be of -2 to the 49th power? Positive or negative? What do you think, Jimmy? Negative. That's right. How do you know it's negative, Jimmy?
Because there are odd number of numbers.
Yes. There's 49 -2s. And if there's 49 negative symbols floating out there, you can have 49, it doesn't matter. One of them's not going to be able to pair up. The other 48 will, one of them's not. Makes your whole answer negative. So it's going to be really, really small answer, isn't it? Because it's going to be some really huge negative number, which means it's very, very small. All right. So there's, I guess in summary, you can write it in your own words. There's 49B and 49C. Okay. You guys have 4 minutes. Pull this up, see if you can get a couple of them done. Vander.
Do we get a paper copy?
Yes, I have a paper copy for you. I forget because there's only 4 of you, 6 of you in here. I forget that you guys get paper copies. Seth, will you grab that stack of paper copies back there in the corner of right there on top of the shelf there? Yes, bring those up to me.